Algebra Word Problems, number 34B. Write, solve equations for work problems, part 2. Work problems involve finding the rate that two or more people working together can do a job. And if we know the rate that each works alone, we can find the rate at which they work together. So by herself, Tala can trim fruit trees in 2 hours. Emma can do the same job by herself in 4 hours. Working together, how long will it take them to trim the trees? So look, Tala takes 2 hours and Emma takes 4 hours. So we make our big box. How much of the job could they each do in 1 hour? Well, if it takes her 2 hours to do the whole job, after 1 hour, she's only going to have half the job done. And if it takes her 4 hours to do the job, after 1 hour, she's only going to have 1/4 of the job done. So now we have our fractions that we need to solve this problem. We're going to let x equal the time it takes for them to do the job together. So we add the fractions, and 1/2 can't be added to 1/4 until the denominators are the same, so we multiply 1/2 by 2 for the numerator and denominator, and we get 2/4. Now we can add them. 2/4 plus 1/4 equals 3/4. We multiply them by x, the time it takes for them to do the job together, and we have 3/4 x. We set the sum to equal 1, and we have 3/4 x equals 1. Now we multiply both sides by the reciprocal of 3/4, the upside down version of it, 4/3, and that's going to get x by itself. 4 times 3 is 12, over 3 times 4 is 12, and now this cancels out as a 1. And you know we don't write the 1 in front of the variable, we know there's only one x there. So we have x equals 1 times 4/3, which is 4/3. 4/3 simplified is 1 and 3/1/3 hours. So we know it's going to take them 1 1/3 hours together to trim the trees. See? All right, let's try it again. Emma can wash her apartment windows alone in 1 hour. Bob, working alone, can also wash the same windows in 1 hour. If they work together, how long will it take them to wash the windows? So we think Emma equals 1 and Bob equals 1. So how much of the job could each do in only 1 hour? Well, Emma could do the whole thing and Bob could do the whole thing. 1. There's no fraction. It's a 1 and a 1. So we're going to let x equal the time it takes them to do the job together. We're going to add the fractions, or the amount of time it takes them to do the job in an hour, and they can each do the whole job. So that's 2. 1 plus 1 is 2. So now we have 2, and we're going to multiply it by x, the time it takes them to do the job together. And we're going to set the sum to equal 1. And now to get the x alone, we divide both sides by 2. This becomes a 1. 2 over 2 means 1, and we can discard it because we don't show the 1 in front of a variable. And x equals 1/2, so it takes 1/2 an hour for them to do the work together. So if you ever have a problem where it shows that they each can complete the whole job in an hour, well, then you know that it'll be 1/2 hour. Now, if it's 3 people, you're going to have 3x if they can each do the job in an hour. And let's say we have Lisa here, and she also could do the job in an hour, then we would have 3x, wouldn't we? Because we would have added these up that they could each do them in an hour, and we would have had a 3. We would have multiplied it by x. It would have been 3x. We would have set it to equal 1. We would have divided it by 3. And then they could all 3 wash the windows together in 1/3 of an hour. See? So it depends on how many people are doing the job, okay? If 2 people do the full job, then it's 1/2. If 3, then it's going to be 1/3. And I bet you if it's 4, it's going to be 1/4. So I'm going to do one more to help you. One last quick video for doing work problems, and then we're going to work on mixture problems. I hope these are helping. Keep trying. I'm sure you're doing a good job, and I'll see you next video.